In this video, we're going to talk about 4 different properties of inverse functions. First thing I want to say is that, so let f denote a one-to-one function. Please let that criteria continue for all 4 properties. It is important because if f is not a one-to-one function, f doesn't have an inverse. So this is important. All right, first thing, note that the first property is that the domain of f equals the range of f. And this makes sense because, when you're thinking about an inverse function, an inverse basically inverts x and y, okay? So, all the values of x that were allowed to go into the function f now equal all the values of y that are allowed to go into the function of f inverse. Okay, so remember, an inverse functions basically invert what x and y are. So, same thing goes for the range. The range of f is the domain of f inverse. This is a really helpful property, and later we'll use it in another example. Basically, sometimes it's easier to find, either the domain or range. A lot of times it's easier to find domain than it is to find range of a function. So if we can find the domain of f inverse, then we'll have the range of f. And so that can be really helpful. So we'll use this property later in another video where we're finding domain and range of f. Okay, so now let's do the next property. So the next property is that f inverse of f of x equals x for every x in the domain of f. So let's do an example. So say f of 3 equals x. In other words, here x equals 3, y equals 5. Okay, so if someone were to say, okay, so what is f inverse of f of 3? Okay, so say you didn't have this property, you just, were trying to figure out what is f inverse of f of 3. Well, let's go ahead. We know f of 3 is 5, right? That was given to you right here. All right, so now what's f inverse of 5? Okay, remember, for inverse functions, you take in the y and then you get out the x. So this is going to equal 3. So f inverse of f of x, or of f of 3, so f inverse of f of 3 equals 3, right? And that's basically exactly what this property is saying, that, if you take the inverse of the function, or the f inverse of the f of x, what you get out is x. So in this case, x is equal to 3. Alright, the next property, this is very similar to the previous property, it's just in the other direction. So here we have f of f inverse of x equals x. So basically these, f and f inverse basically cancel, and the only thing you're left with is x. So let's do an example. So for reading this, f inverse of 1 equals 2. So basically y equals 1 and x equals 2. Okay, because this is the inverse function. So if I was trying to figure out f inverse of 2, of 1, then I would go ahead and plug this in, and so I know it's 2, okay, and because it's given here, so f inverse of 1 is equal to 2, so I just plug in 2, and then what is f of 2? Well, f of 2 is equal to the y value, which is 1. So this equals 1. Okay, so f of f inverse of 1 equals 1. So you see this property is holding. Okay, now let's move to the fourth and final property that we're going to talk about. So this one says, if g is any function such that f of g of x equals x, and g of f of x equals x, then g is the inverse function. Okay, so this was the second property. So if g is the inverse function, this is the second property. If g is the inverse function, then this is the third property that we discussed. Okay, so it's just saying that if both these hold, then G must be the inverse function. So let's go ahead and use this to verify that the following are inverses of each other. So I'm gonna so to do this, I'm gonna find what is f of g of x. Okay, if this equals x, then I'll be on the right track, and then I'll need to find g of f of x, and if that equals x, then I can verify that g is indeed the inverse function. So let's go ahead, we'll find this. So I'm gonna go ahead and plug in g of x everywhere I see x in f. Okay, and then I'm going to go ahead and plug in the value for g of x. So that would be 5 minus x over 2. I'm going to do some simplification. The 2's cancel, and so I'll have 5 minus x, and this is in parentheses. So that is 5 minus 5 plus x, if I distribute the negative sign. And these cancel, so I'm left with x. Okay, that's the first part. Now I need to find that g of f of x. I have to find that this equals x as well. So first thing I'm going to do is I'm going to plug in f everywhere I see x and g. So I'll have 5 minus f of x divided by 2. Right, I'm using this function. I plugged in f of x for x. I'm going to go ahead, now I'm going to plug in what f of x equals. So that is 5 minus 2x, it's in parentheses, divided by 2. Let me distribute the negative sign, plus 2x divided by 2. So these two cancel. So I have 2x divided by 2. This cancels with that, and I get that this equals x. Alright, so both f of g of x equals g of f of x equals x. Okay, so therefore g is f inverse due to property number 4.